All right, the directions say factor the polynomial, and normally when I'm factoring, I always try to see if there's a greatest common factor first. 121, the only thing that goes into that is an 11, which does not go into 49, so there's no greatest common factor. It's not one of those special trinomials, it's actually a binomial, and this is a special binomial, and you have to recognize it for what it is in order to factor it. It is actually what they call a difference of two squares. A difference of two squares. And it helps to know your perfect squares. And your perfect squares are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225. I think that's first 15. So this is, that's 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared, 11 squared, 12 squared, 13 squared, 14 squared, 15 squared. When I used to teach high school, I used to make my students memorize those first 15 because it's easier to just know them. It takes a lot less time because when you look up here, I've got a 121, that's a perfect square, and I got a 49. Here, let me use a different color for that. I got a 49, that is also a perfect square. And not only that, but the 121, it's 121. It's 121 b squared, which b squared is b times b. And then you've got a 49 c squared. When you have a difference, and this is a subtraction sign, that is what a difference is, these factor into what they call binomial conjugates. The 121 splits to be 11 times 11. That is 11 times 11. When you take 11 and square it, 11 squared, difference of two squares, get it? 11 squared, you get 121. But then you've also got that b squared, so you're going to put one of the b's here and the other b there. 11b times 11b. Then for the 49, that comes from 7 times 7, so you put a 7 here and a 7 there. And the c squared, you got to put a c here and a c there. So 7c times 7c is 49c squared. Now, here is the part that you have to remember. Because it is a difference of two squares, one of these has to carry a plus sign and the other one a minus sign, and it doesn't matter which order you put them in. Because when you FOIL these, whenever you FOIL binomial conjugates, something special happens, and that is outsides and insides always cancel out. Now this is my answer, and this is what I would go type into Mobius, but just to show you with the FOIL method, if you take first times first, 11b times 11b, that is 121 b squared. When I multiply my outsides, 11b times negative 7c, that would be a negative 77 bc. When I do my insides, I'm going to get a positive 77 bc. And then last times last, it's a positive times a negative, you get a negative. And 7c times 7c is 49c squared. And then right here, a negative 77 bc and a positive 77 bc cancel out. And you got no bc's. So what you're left with is the 121b squared and then the minus 49c squared. You're left with a difference of two squares. So in order to factor this, you have to recognize it as, oh, it's a difference of two squares. It came from a couple of binomial conjugates, and I need to know my perfect squares for that. So there you go. Difference of two squares.